What up, party people? Welcome back! And this final installment of solving logarithmic equations. Today, we are going to talk about something very valuable that you're going to need to put into your notebooks. So grab a piece of paper, grab a pencil, grab a calculator, scientific calculator at that. And in this final shorter little version, shorter part of our series here on solving logarithmic equations, we're going to talk about the change of base formula. So the change of base formula is a formula that helps us evaluate a log with a base and an input. Okay, so a change of base formula helps us evaluate a log with a base and input. Remember, evaluating a logarithm tells us to find the value of it. So this handy-dandy formula will help us use our calculators to figure out a number that is equal to this logarithm. Okay, so the change of base formula that you're going to need to write down in your notebook is log base b of a, or log base b of your input, whatever, is equal to log of a, log base 10 of a, mind you, divided by log of b. Okay, so just a single log of a, the bigger number of your logarithm, divided by log of the base. Okay, and the easiest way that I remember change of base is that the base goes on the bottom. Okay, so b is base, goes on the bottom. Okay, base goes on the bottom. That's just the easiest way to help me remember the change of base formula. So I think you're gonna like these. Let's get into some examples. Let's just hop right in, shall we? So our goal is going to be to find the value, evaluate. So if I gave us this problem, right? Evaluate log base 81 of 27, right? Normally, we'd say, set this equal to x and say 81 to what power is equal to 27, right? And this is kind of hard. We might need to do a little bit of guess and check or do some converting and stuff. But the beautiful thing about change of base formula is this will tell us exactly what it is, right? So that's what we normally would do. With change of base, we're going to say that log base 81 of 27 is equal to log of 27 divided by log of 81. Remember, the base goes on the bottom. And then what you do is you're just going to take your calculator, find the log button, hit it, input 27, and divide by log of 81. Don't we just love calculator work? Log of 27 divided by log of 81. Hit it, and I get this is equal to 0.75. Boom. You may have been able to guess and check that. You might not have been. Now, just to check our understanding, you could check. You could say, is 81 to 0.75 actually equal to 27? And you could use your calculator to verify that 81 to the 0.75, it's kind of dark, is 27. It checks out. But also remember 0.75 is the same thing as 3/4. And just to verify our understanding and go back to what we learned last unit, that really means 81 to the 3/4 power is equal to 27. We know this to be true, but remember, the denominator becomes the index of your radical. So this is the 4th root of 81. Whenever we're dealing with numbers, I told you to leave the numerator on the outside. And the 4th root of 81, just so happens to be 3, because 81 is 9 times 9, and 9 times 9 is 3 times 3 times 3 times 3. 4 of a kind breaks free of a 4th root. So I really have the 4th root of 81 is 3. We're cubing that value, and that should equal 27. And of course, 3 times 3 times 3 really is 27. But it might have been hard for you to figure out 3/4. This is taking a lot of time. Change of base handles it. Not only does it handle it, but in the case where this conversion is simple and easy to figure out, it also gives us a way to check our work, to make sure we solved our exponential function, our exponential equation correctly. Okay, who doesn't love a self-checking system? Everybody loves it. That's why. Everyone loves it. So change of base is really awesome and really straightforward. So let's keep practicing it, shall we? So let's evaluate this problem, okay? Just with change of base. Let's evaluate log base 16 of 64. If we were going to use change of base, this is going to be log of 64 divided by log of 16. Remember, the base goes on the bottom. Using our calculator, find the log button, type in 64 divided by log button of 16. Boom, I get 1.5. Awesome. Awesome. So log base 16 of 64 is 1.5. Now, what if you don't have a cool calculator like mine? What if you don't have a cool calculator? What if this is what you're working with? Don't worry. Turn your calculator sideways. You've got a scientific calculator. And notice that to the left of 4, it says log base 10. So here's the tricky thing. You have to type the input in first. So, 64, then log base 10, divided by, make sure you hit the input first, 16, log base 10, enter, and you get 1.5. So if you're working with an iPhone, you have to do the input first, then the log, division sign, input first, then the log, equal sign, in order to get 1.5. So you got to get used to your calculator that you're going to be using for this. And again, we could verify that this is true. 16 to what power is 64? We know that 16 to the first power is 16, but 16 squared is too big. It's way bigger than 64. So you might get lucky and guess 1.5 way back when we were trying these. But change of base handles it for you. It's awesome. And I could check. I could see is 1.5. 16 to the 1.5 power. Yeah, it's 64. Check it out. Boom. Amazing. What about log base 5 of 36? Okay, this problem has no solution. 5 to what power is equal to 36 is literally impossible to figure out. There's no way I can do any finagling to figure this bad boy out. So, change of base it is, all right? This is going to be log of 36 divided by log of 5. Remember, this is log base 10. Base goes on the bottom. So grab your fancy schmancy calculators. I'll show you on an iPhone again, because why not? Okay, turn it sideways. The number to the left of 4, the input is log base 10. So remember, we're going to have to put the input in first. So 36 log divided by 5 log equals 2.226. Now, sometimes you're going to get a decimal approximation, so I'm going to say 2.227. And just go to 3 decimal places, or if MathXL tells you a specific value, then you do that. Cool. Let me just double check, make sure on my regular handy dandy calculator. Log of 36 divided by log of 5. Boom, 2.225656505. Cool, same thing. Don't we love change of base? It's a good time. It is a good time. Now, I have a challenge for you, okay? A challenge problem for you that's kind of change of base related, but kind of all of our knowledge learned up to this point, okay? So challenge. And I want you to take a minute to think about what you could do to solve this before finishing the video. Challenge. Our goal is to find the solution of this expression, okay? Find the solution that makes this true. Okay, I'm going to say log base 8 of x divided by log base 8 of 6 is equal to 3. Okay, find the solution. Find the x value that makes this true. Think about it. Take a second. Bing! How would we figure out what x has to be? How do we find this solution? Hopefully you've had a chance to think about it. Hopefully you tried something. It never hurts to try. But I've got log base 8 of x divided by log base 8 of 6. It kind of looks like a change of base, right? And I guess it kind of looks like it, but the base is different. So I can't like convert it back to log base b of a. But what I can do is use my inverse operations because I want to get x alone, right? Solve for x. So I need to get rid of the denominator here. Let me multiply both sides by log base 8 of 6. Whatever I do to one side of the equal sign, I have to do to the other. These cancel. I'm left with log base 8 of x is equal to 3 times log base 8 of 6. Now, this didn't help me, but I'm almost at a log equal to a log. If only there was a property I could use to get rid of that pesky 3. Oh my gosh. Power property. So I have log base 8 of x is equal to log base 8 of 6 to the third power by the power property. And once I have a log equal to a log with the same base, log base 8, whatever the input values can be set equal to each other in a new equation. So I've got x is equal to 6 to the third. And then voila. 6 to the third is what? I don't know. Calculator says 216. Sweet. But we better check and make sure this is true, okay? Not only because we used a property of logarithms to make sure it's not extraneous, but like, don't you want to make sure that like you got the challenge right? We love a self-checking system. So let's see if log base 8 of 216 over log base 8 of 6 is really equal to 3, right? And when I have a quotient, I can use, I wonder, So what I was thinking to myself was, I wonder if I can simplify this equation. But I had to remind myself what the property of logarithms says, right? The property of logarithms says that if I had subtracted something, it can become this quotient. However, I don't know if this was subtracted, and this is a quotient with the base kept each time. It's not log base b of m over n. I have log base b of 216 divided by log base b of 6. So this isn't the quotient property. I can't divide 216 over 6. So it ends up giving me a false answer anyway. But that's what I was thinking, to myself. However, we did just bring up change of base. So I could check if this log in change of base divided by this log in change of base is actually equal to 3. So let's do that. Okay? So the numerator is actually log of 216 divided by log of 8, right? That's what change of base says. Log of the numerator divided by log of the denominator. The base goes on the denominator. And I'm just writing it out this long way for formatting purposes of a double-decker fraction, divided by log of 6 divided by log of 8. Remember, the base goes on the denominator. And I'm just going to use my calculator to do this calculation. So I'm going to type in log of 216 divided by log of 8. And I'm going to get some sort of decimal approximation, 2.584 if you really want to like write it down. This is about 2.5849, so I'm going to round up 2.585. And log of 6 divided by log of 8 is about 0.862. So if I do 2.585 divided by 0.862, now I'm cutting off these decimals by a lot. So as long as it's really, really close to 3, I'll be satisfied. And look, it's 2.998. Yep, that is almost 3. So I would say that that's a true solution. Or if your calculator is cool, you can just keep up with the division. So what I would do personally is I'm going to take log of 216 divided by log of 8. See it? Typed it in. Hit enter. And then click divided by, because it's going to take this answer. And just throw in some parentheses. Log of 6 divided by log of 8, close the parentheses, and you'll see that I get actually the number 3. But if your calculator isn't that cool or you're not sure, you can do this approximation as long as it's really, really close. That would work too. Pretty cool. Awesome. Thanks so much for tuning in today. Next class, we're going to talk about how to solve exponentials. So don't worry. We've got all these great tools in our toolbox. Have a great day.